Now, a question like this people have trouble with. What we have 3 right-angled triangles. We've got one here, and then we've got the big one that we're in. But like any other question when we're trying to solve for x using similar triangles, we have to label first. So it's A, B, C, D. Now how you label is completely up to you. You can use X, Y, Z, Q, U, R, S, T, up to you. So now what we have to do, we look at what we've got. We've got 3 right-angled triangles. We've got 2 smaller ones and 1 big one. When it comes to finding x, we can't use the big one because we don't have enough information. We don't have the length AB or AD. So what we're going to have to focus on is the 2 smaller ones to find x. So we can't use our laws of parallel lines because we don't have it. So we have to let an angle equal something. So what we're going to do, I'm just going to let this angle here equal alpha. Okay, so let angle A, B, D equal alpha. Now there's a reason behind that. Because we have a right angle triangle, that means angle BDA, this one here, has to be 90 take alpha. Okay, because this one's over here's alpha. Now we also have a right angle triangle ABC. So therefore this angle up here, angle CAB, there is also going to be 90 take alpha. Alright, which would have to make this angle here for the other triangle ACD, well that has to be then alpha because of 90 degrees in a triangle, or 180 degrees in a triangle, and because it's a right angle triangle we're left with that. So let's just see, so therefore angle BDA, so A equals 90 take alpha. Reason why, angles in a triangle. Alright, also therefore, because we've got that, angle CAB also equals 90 take alpha. Same reason, 9 angles in a triangle. So then we have angle so we have angle now DAC equals alpha. Now as you can see, we have the 3 angles. So what we're going to use triangle CAB and triangle CDA. Okay, that's what we're going to use to prove similarity. Now, as you can see, we've sort of already proved it because we've got our 3 angles. We've got the 90 degrees here, we've got the 90 take alphas and the alphas. So we're pretty much there. It's been proven that they're similar. So now that we have CAB and CDA, as you can see, I've tried to keep it consistent. I've started at the right angle here at C, and then I've gone around to 90 take alpha, and then to alpha. So that's CDA, and then it's CAB, depending on what triangle we're looking at. And that's how from here, we can go on to find X. So we have CA, our loop, CA. So the length of CA is X. So CD that's going to be over 2. equals CB, which is 3, over CA, which is X. Now, we can go in, cross multiply. So that's just come up here. So now we have X squared equals 6. 3 times 2 is 6. So X equals plus or minus the square root of 6. So now it's plus or minus. We can't have a negative answer because we're talking about length here. So mathematically, yes, we have 2 answers, but realistically, when we're talking about a unit of length, we only have 1. So X equals positive the square root of 6 centimeters, and leaving it in surd form is fine. Now, if you want to make sure and go through, you can then, up here in the similar triangles, you can say that angle ABC is equal to angle DAC, and reasons why, but this information here is enough for the similarity.